Hello, I am David W. Parker. This is Programming Today I Learned, Math Series, 3D Math Series, Episode 10, Part 4 in Matrices, and we're going to be looking today at how to multiply a matrix with a vector and how matrices affect vectors. So let's get right into it. Row vectors versus column vectors matter, and we'll see exactly why in just a moment. So first of all, we have this row right here times this matrix, row vector times this matrix, and this is the solution to that problem. As you recall, you can remember that this 1 by 3 matrix, also known as a vector, can be multiplied by a 3 by 3. And you'll see how we have M11, M21, M31 as the first values, etc. Now multiply it by a column vector, and it has to be in the second position, because the 3 by 1 would not be able to multiply by a 3 by 3 because the 1 does not match up with the 3. So you could see that the first value is going to be M11, M12, M13 multiplied by x, y, and z respectively. So you could see there's already a difference in the first value and each subsequent value. Also note that these, if you try to do the other ways, they are both undefined. That does not work. So what do we want to know about these? Well, first of all, note that, like in the previous slide I just said, that row times m, the matrix, is not the same as equal to m times the column. So it's important to know what you're working with. So depending on whose code you're looking at and who you're working with, what type of graphics you're doing, you will need to know this in order to do things properly. In general, DirectX uses row vectors. I'll be mostly using row vectors in most of my tutorials. OpenGL uses column vectors, so if we jump back to some WebGL things, we may end up jumping over to column vectors for sometimes. And linear algebra books generally use column vectors as well. So how do matrices transform vectors? So take this vector xyz and recall that it's just the chain of x 0, 0 plus 0, y 0 plus 0, 0, z, and you can rewrite this and extract out the x, y, z and have the identities of each respectively. So then rewrite each of these unit vectors p, q, and r. So that's a unit vector, if you recall. And so you have this vector v is equal to xp plus yq plus z and r. In this instance, p, q, and r, these unit vectors, are known as base vectors. So using those, you can go ahead and make this matrix with the x, y's, and z's respectively to see, we're going to use that to multiply by that x, y, z vector. And you can see, so here's the row times the matrix as I stated. So we're going to end up with this result, and you can see that this is basically just x times p vector, y times q vector, z times r vector. So what does this all mean? It's kind of complex, and I'll try to word it down, but basically if the rows of a matrix, use the rows of a matrix as the base vectors, as I said before, of a coordinate system, then multiplication by the matrix performs a transformation on that. So this is the complex way to say basically a vector here multiplied by some matrix is a new vector, then we say that this m, the matrix, transformed A to B. That's basically it. It's super simple. And so in these instances, we'll be using multiplication synonymously with transformation. And so matrices aren't that crazy or different. They're pretty simple once you actually just sit down and write out all the really small steps to compute the dot products and whatnot. And they're great, just a great way to transform from one coordinate space to another. So that's it for this episode. If you like what you saw, go ahead and subscribe, like this on social media, and share if you will, and give me a thumbs up, and I will talk to you later. Go to ProgrammingTIL.com and sign up for our newsletter. Thanks. Bye.